Welcome to Paper Trail, where we make academic research accessible and engaging. Let's see what the evidence says.
There's a prevailing narrative right now that AI is on the verge of significantly changing software development, even to the point of designing entire systems from the ground up. But recent analysis suggests this might be more illusion than reality.
That's precisely what the research indicates. While AI is undeniably powerful at generating code, optimizing existing systems, and even debugging, the fundamental act of architecting software from scratch, particularly understanding the abstract, strategic layer, remains firmly in the human domain.
So despite all the impressive demonstrations of AI writing functional code, it's not actually thinking like an architect. It's not planning out the blueprint in the same way a human would.
Not in the strategic, conceptual sense. It's more akin to having an incredibly fast and knowledgeable construction crew that can build walls, lay pipes, and wire electricity with astonishing efficiency, but they still need an architect to hand them the comprehensive, high-level blueprint and explain why certain design choices were made for the long-term vision of the building.
That's a crucial distinction. When discussing building software from scratch, many might imagine AI simply taking a few high-level prompts and churning out a complete, robust system architecture. What does the research pinpoint as the core limitation preventing AI from doing that?
The core limitation lies in what's called abstract requirements understanding and strategic decision-making. Human architects typically start with incredibly vague, often conflicting business requirements. Think, we need a faster way to process customer orders, or our data needs to be more secure and scalable. An AI can't currently translate these ambiguous human-centric goals into concrete, actionable software components and architectural patterns in a truly novel way.
Because those initial business problems aren't typically expressed in code or even in structured data that an AI can easily ingest and learn from, it's more about unspoken needs, implicit trade-offs, and future unknowns.
Exactly. Consider the process. A human architect will sit down with stakeholders, ask probing questions about budget, timeline, desired user experience, regulatory compliance, long-term growth projections, and even team skill sets. They're gathering information that isn't just about what the software should do, but why it needs to do it, and what broader business context it fits into. This requires a level of contextual awareness and common sense reasoning that current AI models simply do not possess.
So it's not just about parsing natural language, but understanding the implications of that language in a business and technical ecosystem.
Precisely. An architect might hear, we need to scale rapidly, and immediately start thinking about microservices, cloud-native deployments, asynchronous communication, and eventual consistency models. This isn't just a direct translation, it's an inferential leap based on years of experience, understanding the pros and cons of different paradigms, and predicting future challenges. AI, trained on existing codebases and architectural patterns, can suggest relevant solutions, but it struggles to originate these strategic choices or deeply interrogate the underlying business drivers behind them.
So it can suggest a microservices architecture if it's seen that pattern associated with scalability, but it can't truly weigh whether that's the right choice for this specific company with this specific team and these specific constraints.
That's a perfect way to put it. AI can retrieve and synthesize information from its training data, which might include discussions about microservices and scalability. But the critical part, the why and the how it specifically fits into a unique, evolving context, is where it falters. Human architects engage in complex trade-off analysis. They might decide that a monolithic architecture, despite its scaling challenges, is a better initial choice because the team is small, the budget is limited, and time to market is paramount. An AI doesn't have that nuanced judgment.
The analysis also highlights the challenge of strategic decision-making and trade-off analysis. Software architecture is often about balancing conflicting non-functional requirements: performance versus security, cost versus flexibility, time to market versus long-term maintainability. How does AI fare in these complex scenarios?
This is another major hurdle for AI. Architectural decisions are rarely clear-cut. They involve navigating a multi-dimensional problem space with conflicting objectives. For example, enhancing security often comes with a performance overhead or increased development complexity. Optimizing for extreme scalability might introduce significant operational costs. Humans excel at weighing these factors, often relying on intuition, experience, and the ability to foresee potential future problems.
So a human architect might say, given our current budget and regulatory environment, we'll accept a slightly less performant system in favor of ironclad security for this specific component. And AI wouldn't make that kind of judgment call organically?
No, not yet, and perhaps not ever in the truly human sense. AI can be fed constraints and objective functions, and it can optimize within those parameters. For instance, you could tell it to prioritize security over performance by a factor of X. But defining that prioritization, understanding the subjective value of ironclad security versus slightly less performant, and making those judgment calls in the face of incomplete or ambiguous information, that's a profoundly human cognitive task. It requires understanding risk tolerance, brand reputation, and even the emotional impact of a security breach, none of which are easily quantifiable inputs for an AI model.
It sounds like AI is excellent at optimizing within a defined problem space, but not at defining the problem space itself, especially when that space is fuzzy and qualitative.
Precisely. Think of it like this. If you give an AI a perfectly specified mathematical optimization problem, it can often find solutions that human experts might miss and do so far faster. But translating a messy, real-world business challenge into that perfectly specified mathematical problem with all its inherent trade-offs and human values, that's the architect's job. The paper suggests AI's current capabilities are more about pattern matching and extrapolation from existing data. It can recognize common architectural patterns associated with certain problems, but it struggles to innovate truly novel solutions for unprecedented challenges or to make nuanced judgments where no clear best practice exists.
This leads to the idea of the illusion itself. If AI can generate a lot of code and even suggest architectural patterns, it can create a strong impression that it's doing the architect's job. What's the subtle but critical difference that makes this an illusion?
The illusion arises because AI can mimic the outputs of architecture, such as diagrams or code structures, without performing the underlying cognitive processes of architectural design. It can generate boilerplate for a microservices architecture, complete with API gateways and service discovery, because it has seen millions of examples of such architectures in its training data. It can produce documentation that looks like an architectural decision record.
So it's like a highly skilled parrot that can perfectly recite complex technical terms and even construct grammatically correct sentences about system design, but doesn't actually understand the meaning or implications of what it's saying.
That's a good analogy. The AI operates on statistical relationships and patterns. It learns that certain keywords or problem descriptions often lead to certain architectural solutions in its training data. It can then generate text or code that appears to address the problem, often impressively so, but it lacks the deep causal understanding of why those patterns work or the ability to reason about their suitability for a truly novel context where the patterns might break down. It's sophisticated pattern matching and synthesis, not genuine invention or strategic foresight based on understanding the world.
This implies that if you ask an AI to design a system for a problem that is truly unique, or where conventional patterns are suboptimal, it might struggle to come up with something innovative, or even something appropriate.
Exactly. Its strength is in recognizing and recombining existing knowledge. If a problem falls outside the distribution of its training data or requires a fundamentally new approach, an AI is far less likely to generate that novel solution than a human architect. Humans can draw analogies from completely different domains, apply first principles reasoning, and synthesize disparate pieces of information to create something genuinely new. AI's creativity, for lack of a better term, is combinatorial within its learned space, not generative outside of it.
So if an architect is like a master chef creating a new dish from scratch, blending flavors in innovative ways based on deep understanding, AI is more like an incredibly efficient recipe generator, able to combine and adapt existing recipes, but not fundamentally invent a new cuisine.
That analogy holds up well. The chef understands the chemistry of ingredients, the palates of diners, the cultural context of food. The AI recipe generator can give you thousands of variations on existing recipes and even suggest new combinations based on popularity or ingredient availability. But it doesn't understand flavor in the same way a human does, nor can it create a dish that perfectly caters to an unstated, nuanced desire. It lacks the intuition and the ability to grasp the abstract, subjective qualities.
Given these limitations, what does the research suggest is the evolving role of the human software architect in an AI-augmented future? It sounds like they're not going away.
Far from it. The role of the human architect becomes even more crucial, but it shifts. Instead of being bogged down in boilerplate code generation or researching standard patterns, architects will be freed up to focus on higher-level strategic thinking. Their role will be to define the problem, understand the deeply nuanced business context, articulate ambiguous requirements, and make the critical, high-stakes trade-off decisions that define a system's long-term success.
So AI becomes a powerful assistant, not a replacement. It handles the tactical execution, allowing the human to focus on the strategic vision.
Precisely. Architects will leverage AI as an incredibly powerful tool for accelerating their work. They can use AI to generate initial drafts of code, explore different implementation details, identify potential performance bottlenecks, or even suggest common architectural patterns for specific subproblems. But the human will remain the ultimate arbiter, the one who synthesizes all this information, applies judgment, and makes the final strategic choices based on a holistic understanding of the problem and its environment.
This implies that the skill set for architects might also evolve, less about rote memorization of patterns and more about critical thinking, problem definition, and guiding AI tools effectively.
Absolutely. The emphasis will shift from tactical knowledge to strategic wisdom. Architects will need to be adept at clearly articulating complex problems, specifying constraints, and evaluating the outputs of AI with a critical eye. They'll need to understand AI's strengths and weaknesses to effectively prompt it and interpret its suggestions, ensuring that the generated solutions align with the broader, often unquantifiable, business objectives and values. It's about elevating the human role up the abstraction ladder, focusing on the unique aspects of human intelligence, intuition, judgment, and the ability to handle true novelty and ambiguity.
So, to summarize, the paper points out that while AI excels at pattern recognition, code generation, and optimization within defined constraints, it cannot currently perform the abstract understanding, strategic decision-making, and nuanced trade-off analysis that defines true software architecture. It mimics the form of architecture without the underlying function of human judgment.
That's the core finding. The illusion is that the impressive tactical outputs of AI might lead one to believe it's performing the strategic work, but the reality is a significant gap remains in its ability to handle ambiguity, make subjective trade-offs, or originate truly novel designs for unprecedented problems.
So, for listeners thinking about the future of software development, the key takeaway here is that human ingenuity, especially in abstract problem-solving and strategic design, remains indispensable. AI is a powerful enhancer, but not a replacement for the architect's mind.
It's about augmentation, not automation of the entire architectural process. The human architect will define the destination and chart the course, with AI providing an incredibly efficient means of navigation and construction along the way.
That makes a lot of sense. It also raises an interesting question. How much more sophisticated would AI need to become to genuinely bridge that gap in strategic architectural thinking? And if it ever did, what would that imply about the nature of intelligence itself?
That wraps up this episode of Paper Trail. Join us next time as we dig into more research worth talking about. If you liked what you heard, share it with a friend.
Keep reading the fine print.